Hello everyone, this is Kalima Alan, and today I'm going to review an article called Early Detection of Coronary Heart Disease based on Machine Learning Methods. This article was written by Rustem Yilmaz and Fatma Hilaria Jin. The academic editor was Mohammed Hamoudel. It was published on 1st January 2022, Volume 4, Issue 1. These are the references, and the link to the article will be in the description. In the article, they use a dataset from IEEE Dataport. The link will be provided in the description. And this dataset was a combination of Cleveland, Hungarian, Switzerland hard dataset, and Long Beach VA datasets. This is the description for the dataset showing the age, sex, and all other attributes, the code given, the unit, and the data type. The problem they aimed to solve was to address the challenge of predictive classification of coronary heart disease using the machine learning methods. And they did this through comparing the performance of different machine learning algorithms in accurately classifying in individuals with coronary heart disease based on the patient's attributes and clinical data. Three models were created. One used random forest, the other support vector machine and logistic regression. They chose random forest because it is good at detecting the noise and outliers and also solves the problem of overlearning. While support vector machine often delivers the better categorization results due to its ability to detect patterns and uses hyperlane as a decision surface to optimize the margin of separation between the positive and negative samples. The logistic regression estimates the unknown parameters that maximizes the probability obtained from the data set. For these models, they use the hyperparameter optimization, where a 3 repeats 10-fold repeated cross-validation method was used. This means that the cross-validation was done 3 times for all the models, and the dataset was divided into 10 equal folds, which they used for testing and training. The evaluation metrics that were used, we had accuracy, specificity, sensitivity, F1 score, negative predictive value, and positive predictive value for each model. As we see here, there is logistic regression, random forest, and vector machine, where logistic for accuracy had 0.861, 0.929, and 0.87 for the respective models. The strength of using these metrics, we have rigorous methodology, whereby the study utilizes hyperparameter optimization with a grid search and repeated validation. We have a comparative analysis where they used multiple models, machine learning algorithms, and which shedded light to the effectiveness in heart disease detection. Why? We also have the comprehensive evaluation. Performance was evaluated using various metrics, as we listed before: accuracy, F1 score, specificity, sensitivity, providing a thorough assessment of the model performance. The data limitation, the weaknesses, we have data limitation, where despite using a data set from multiple sources, it doesn't fix a generalizability, which can hinder dataset characteristic of the potential bias. We also have lack of real-world assessment. The study concentrated on the predictive performance of the metric without evaluating the clinical utility of the real-world impact of the models. And methodological constraints are also part of the weaknesses, where the choice of machine learning and algorithm evaluation metric may not encompass all the possible approaches, potentially restricting exploration of alternative methods of the heart disease classification. And according to the article, the results were random forest model outperformed other models with an accuracy of 0.92 and in predicting the CHD. And the confusion matrices that we have below here can show that, where the true positives for regression for random forest were the highest, and they had the least number of true negatives, as we can see here. In conclusion, the paper demonstrates a systematic approach to addressing the computational problem of CHD detection using machine learning methods. The author provide a clear explanation of their methodologies and findings, contributing to the existing body of knowledge on the AI applications in healthcare. And these are my citations and references. Thank you for watching.